The energy that should be added to an electron to reduce its de Broglie wavelength from 10 raised to power minus 10 meter to 0.5 into 10 raised to power minus 10 meter. क्वेश्चन इज अगर कोई इलेक्ट्रॉन है हमारे पास, उस इलेक्ट्रॉन का कुछ वेवलेंथ गिवन है हमारे पास, डी ब्रोगली वेवलेंथ विच इज 10 रेज्ड टू माइनस 10 मीटर. क्वेश्चन इज हम इस इलेक्ट्रॉन को कितनी एनर्जी और दें so that its de Broglie wavelength lambda becomes 0.5 into 10 raised to power minus 10 meter. ये क्वेश्चन पूछा. We know lambda de Broglie is equal to Planck's constant h by root of 2 times m into e, where h is Planck's constant, m is the mass of charged particle, and e is the energy of charged particle. So this implies wavelength lambda is inversely proportional to root of energy. Okay, so further this is equal to lambda 1. अगर हम इस वैल्यू को lambda 1 मान ले and to this value suppose lambda 2, and this wavelength is corresponding to some energy E1, और ये जो वेवलेंथ है सपोज ये वेवलेंथ है corresponding to some energy E2. So lambda 1 by lambda 2 will be equal to root of E2 by E1. So this is equal to, on putting the values of lambda 1 and lambda 2, 10 raised to 1 minus 10 divided by 0.5 into 10 raised to 1 minus 10. This is equal to root of E2 by E1. So 10 raised to 1 minus 10 say 10 raised to 1 minus 10 will cancel, and we will get 2 times of root of E2 by E1. Squaring both sides, we will get 4 is equal to E2 by E1. या फिर हम बोल सकते हैं E2 is equal to 4 times of E1. So हमें कितनी एनर्जी और देनी पड़ेगी? E2 minus E1 will be equal to 4E1 minus E1, which is equal to 3 times of E1. मतलब 3 times of the initial energy, जितनी एनर्जी पहले थी उसकी 3 times और एनर्जी देनी पड़ेगी, so that wavelength becomes 0.5 into 10 raised to minus 10 meter. So as per option B is the right answer.